scrolling through Twitter fairly recently and look at this. Another DOM XSS challenge from Intigriti. I did the first one. It was freaking awesome. I loved it so much. So, of course, I had to try this one too. So first things first, there's a really awesome feature in Chrome which I use all the time, which is the overrides feature. It just lets you go into the page, you can just edit the code right there and then. Let's just write test, save that, and then every time you refresh the page, your changes will be here. First things first, how we understand the script. Okay, so we're creating a variable here called b64img, which is taken from the value after the hash in your URL. We're then setting up a HTTP request. We're setting on some kind of handler for that. We want to make sure that the content type we get back is of a blob type, and we want to do a GET request on that data. Now, when the HTTP request hits send, that's going to change the ready state, and that is going to hit our new handler. Now we're hitting an interesting part of the script. We're hitting this check when ready state is 4 and when this.status is 200. So when we send off this HTTP request, we're going to start hitting the handler that we set up earlier. And that's where the interesting part of this script comes. This is where we want to get to. First things first, there is a check. This.readyState has to equal 4 and this.status has to equal 200. Now this.status equals 200 is super obvious. It is just the request response. It's a 200 response. That means everything was a-okay. And this.readyState equals 4. Well, if we don't know anything, we can just Google it. And here we have. It just means that the operation of that HTTP request is considered completely done. And once we pass both of these checks, we then get into the meat of the matter, which is going to create us a new file reader, set up another listener on a specific event, and call this specific method, read as data URL, and it's passing in this.response. So once again, through the power of the internet, we are able to Google what exactly that method does. So we understand that this.response is obviously going to be the response from the HTTP request that we did. So the data is obviously going to be blob data that we got back using the payload that we put in after the hash in the read as data URL method is used to read the contents of a specified blob or file. When the read operation is finished, ready state becomes done, blah, 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 blah. Nobody cares. At that time, result attribute contains the data as a data URL, representing the file's data as a base 64 encoded string. And of course, we get a nice little example of what that would normally look like. But screw the example, I want to see what this actually looks like. So, as I said before, because we can do nice fancy overrides, once we get in here, let's literally just console log reader.result. Save that, refresh, and this is the result. It is a data URI, just as it told us, encoded with base 64, and then all of our blob data here. And as you can see, there is a lot of blob data, because this is a large image. So document.write will literally take every character in our string and insert them as is. Zero encoding, zero checks in place. It's going to insert every single character that you put in there into the document. So now we have a pretty good understanding of how this entire application works. From beginning to end, we understand pretty much every line here, what it's doing, and now we can start to think about how we can abuse it. The obvious place that we want to get to is something inside of document.write, but are we going to try and get our payload into the href of the A tag, maybe a JavaScript URI, so when you click on that, it's going to run your JavaScript. It could be in the alt attribute, if maybe there was something we could inject there, or in the image source. So let's start with an idea to start poking around and seeing how the app reacts, okay? So the first thing, as I mentioned, the A tag has an href, which is being taken from the value that we passed in the beginning. So if we could pass in a JavaScript URI, we could have an XSS attack whenever somebody clicked that link. So let's try and add a JavaScript URI. Alert document.domain, which is what they want. So trying to run this, we will see exactly what happens, and we run into our first issue. So if we decide to run this and try to get our XSS through the A tag, we are going to see the following issue. We are being blocked by the browser's cause protection, which is basically, in super short terms, is stopping you from making requests that it thinks is nefarious, so it will do things like making sure that the protocol is the same. In this case, we're talking HTTP, HTTPS, which is the two things that we can view this website under, and obviously we are trying to load something with a protocol of JavaScript. So since those two things don't match, we cannot run this JavaScript URI. Now the thing is, we are not out of luck here because we are inside of document.write, which as I mentioned earlier is going to take every character that you pass in as it is and it's going to embed it in the page. Okay, so let's try something super simple then. Let's just try to embed some tags, right? We're gonna put this directly in the page. Let's see if we can embed some tags. Well, this results in 404, which means we don't pass our check. Now I'm thinking we're in a pickle because we need to have something passed in here in our hash that is going to return us a 200. Now we are not out of luck at this point, because, just as we looked at earlier, the JavaScript URI will return us a 200 response. And so we can look at using other URIs. Now actually we touched on data URIs very briefly earlier while we were looking at the file reader API, but we can simply encode the data we want in base64 and then put that into a data URI. It's super common in web development practices. You can Google all about it. It was used in the first DOM XSS attack. We just open up a base64 encoder, put in our payload here like alert1, and then boom, we have our data URI, which I literally copied off the internet because I cannot remember how to write that manually. It doesn't really matter. We take our base64 that we just encoded and we go along and we put it in and we hit enter. Are you gonna help us? No. Now the reason is ATOB is literally going to take a base64 string, like let's just pass in the string that we just did a second ago, and it's going to decode that string and give us the output in text. Now we don't actually care if ATOB is able to take our string and decode it properly because it's just going into the alt property of this anyway. It doesn't even matter, right? We want to inject all of our stuff directly into that href and embed all the code we want for XSS. But the problem is that every time it errors, it's just going to error out completely. It's an uncaught exception. It's just going, what the hell are you trying to do? I just tried to execute this and you're giving me garbage. So we need to appease ATOB in some way. Make sure that it doesn't freak out at the data that we're passing in. So ATOB is just taking in our payload. And because there's invalid base64 characters, we cannot get our payload through. But I have an idea. If I can inject some script tags into this form, which should be possible because we're using document.write, then we can overwrite the ATOB function to just return some random string or whatever, and then every time we call ATOB, it's not going to try and process it like we expected it to. It's just going to just give us back the string that we defined in the new ATOB function. Now, I thought the idea was good, but unfortunately it failed for two reasons. Number one, URL encoding. I couldn't get the characters that I wanted into the form. Maybe there was a way to do that, I don't know. But even if I could, even if I manually were to write in here some script tags and, you know, do all sorts of nice extra quotes and angle brackets to make it all valid HTML, but while also injecting script tags, it still wouldn't have worked. Now the reason for that is simple. JavaScript is still going to look at this ATOB function and execute that before it gets to my script tags and tries to evaluate my JavaScript where I try to overwrite the ATOB function. Good idea, doesn't work. I'll go over one thing also that I had thought of at the time, which was a very similar concept, which was that the image source takes the reader.result value, which is a blob of data, right? That was what we requested. We requested of type response type has to equal blob. And so what we could have done is make sure that that blob returns an SVG file. And then in that SVG file, we could have an onload handler. The onload would overwrite ATOB, or even, it doesn't even really matter because if we're in an onload handler and we're writing JavaScript, we can just document.alert before ATOB runs. So not only will that fail because ATOB is still going to run first and complain, but also JavaScript handlers will not work inline for SVG elements when they are loaded dynamically. But now at this point, after looking at the SVG thing, my attention started to turn to the image source, and I started to realize that I had been thinking about this all wrong. I had been thinking about what sort of things can we use an image tag for, like an SVG file. Oh, we can add a blob in there and add some handlers or whatever. But remember, we're in document.write. We can inject anything into there. what exactly is this reader.result? Now, this is the result after we converted that blob of data we got back into a data URI, right? That's what we looked at earlier through this read as data URL. And remember, this is a GET request that we just want to make sure it returns a 200. So we can start looking externally. So if we have an external server that we can pass the data back to that gets put into this.response, then we can start injecting our payload into document.write, which will eventually lead us to XSS. But we still have one problem. No matter what we put in as our payload, that atop function is gonna freak out, and I can't override that in any way. So maybe there's a way we can work with atop. But these are all of the available characters as a result of this RFC for base 64. We have A to Z, uppercase, lowercase, 0 to 9, and a plus, a slash, and an equal sign. But unbelievably, you can actually represent an external resource using these characters. So the first trick that we want to use is slash slash. Slash slash just tells the browser that what you want is whatever protocol is being used already on the page. So you don't have to specify http:// or https://. You can just say slash slash browser, go have a look at what we're using, and then just keep using that already. So we have the beginning part set up. We're saying, okay, do it over HTTPS, HTTP, whatever. We don't care, let the browser do it. But how do we represent the actual address? Our host names aren't much use to us because they have a dot in them, and so are IPs. IPs also have got dots in them, and those are not valid base 64 characters. But IPs can be represented in different ways. Look at this. Convert it to a hex value. Convert it to an integer. Both of these will work fine. So now we have just what we need. We can bypass atop. It's saying A-OK, go right ahead. This looks like valid base 64 to me. I'm going to attempt to decode that. It's going to let us put it in. It's going to make a request out, return the data, put it into reader.result where we can inject whatever we like. So let's try right now. Add that on there, enter, and error. Well, that's super easy to fix. It's just saying that there's an issue with the certificate. We don't care about that. We'll just change it to HTTP, and because of this slash slash, it's just going to use HTTP for our second request too. Now we see that we are genuinely trying to make a network request. We can even check the network tab, and there is our request. Now at this point, I have to give a shout out to Damien, who helped me with this. The guy is a freaking genius. I just happened to post in a Discord server that I was doing this challenge. He said, hey, have you done it or whatever? He was looking at some things. We got in a call. I shared my ideas about the SVG, the data URI. We talked for a little bit. We screen shared, and he was the one who showed me the little trick with the slash slash to bypass the atop filter. And he is also the one who set up this. Boom. This is our final payload. It is a super simple PHP script that is super obvious. It is literally going to set us a header with a content type of this arbitrary string, and we will see exactly why that's important in a second. And we're also setting access control, allow origin to be wildcarded, whatever, because we need to bypass the calls issue that we just looked at 1 second ago. So boom, we now have our final payload. Let's run it and see what we get. Boom! We have a server set up, and we were able to inject the data as we requested. Let's take a look. So in our network tab, we can see that it went off, it got the response back, and in our headers that we got back is our payload, and that gets embedded directly into our document here. So as you can see, this is where atop is trying to decode stuff that shouldn't really be decoded, and because we have an injection point and we're inside of document.write, the data that we're sending back is getting put in there as is. And obviously we could just manipulate using quotes and whatever else to make sure that we can embed our on-error alert document.domain. So I then submitted my little write-up explaining how it was done and sent it off to Intigriti. They confirmed it was in fact a valid submission, but one thing was mentioned. This was actually the unintended solution. So, of course, I submitted this to Intigriti. They confirmed it, said it was all good, but did mention I had found the unintended solution. Boom! Second shout out to this guy, Boris Fursing, who actually reached out to me after I wrote in the Discord that I had found the unintended solution. He wanted to know what it was, and he also had his solution, and he shared with me what the official solution to this is. So what he realized is that this slash is still available to us, right? It's a valid base64 character, and we can use that to simply add more data there, that once we reach this alt attribute is going to get decoded properly and put into the page, because this is document.write. Remember, we can have any of our characters that we manage to sneak in there directly embedded in the page. If we take a payload here, add it on the end, and enter that, now I get a 404 because my file does not exist with this file name, but you could easily create a file with this file name that would fetch back the data, and then when this data reaches ATOB, so let's actually manually do it, we'll just call ATOB and we will pass in our entire payload. Let's take all of this minus the hash, because that's what happened in the script, and we will see that the following will get output directly here inside. This is where our rejection point is. It's going to give us a bunch of rubbish because that's part of the IP or whatever, but then it becomes a valid base64. We have to inject our script tag where we can now call document.domain and call XSS for a second time. That's it. That's how we completed it. That was my journey from beginning to end. Not a write-up. If you want to view a write-up, I'm sure there's going to be many by the time this video comes out. But don't forget to follow these two guys on Twitter. They did amazing. And of course me as well. Good sniff. Follow me.